Have you ever tried to visualize a world beyond the three dimensions we are familiar with? It's quite the mind bender, isn't it? Let's start with the basics. Imagine a line. This line represents the first dimension, length. Now, if we draw another line perpendicular to it, we've added a second dimension, width. We've essentially created a flat, two-dimensional plane like a sheet of paper. But we live in a world that's not just flat. We can move up and down, left and right, forward and backward. This is because of the third dimension, depth, which adds volume to our world. You can think of it like a cube, which has length, width, and height. But here's the kicker. What if there was more? What if there was a way to move that isn't confined to the three dimensions we know? So what if there was another dimension that we simply cannot perceive? Imagine a world where time is not just a measurement, but a dimension you can move through, just like length, width, and height. A mind-bending thought, isn't it? But that's the essence of the fourth dimension, time. Let's delve deeper. Picture a book. It has length, width, and thickness. These are its three dimensions. Now imagine reading that book. As you turn the pages, time passes. That's the fourth dimension. It's as real as the other three, but we experience it differently. We can't move back and forth in time like we can in space. But why is that? Well, it's all about perception. Think of a movie. Each frame is like a three-dimensional snapshot of the world at a specific moment in time. If you stack all these frames in order, you create a four-dimensional block. We, as three-dimensional beings, can only perceive one frame, one moment at a time. And we perceive these moments in a linear fashion, one after the other, just as you'd watch a movie. Now let's get adventurous. What if we could perceive more than one moment at a time, or move back and forth through these moments? This is where the concept of time travel comes in. If time is just another dimension, then theoretically, we should be able to navigate it, just like we navigate through space. Imagine the implications. We could revisit the past, see the outcomes of our decisions before we make them, even meet our future selves. But remember, this is all theoretical. Our current understanding of physics doesn't allow for such time travel, but who knows what the future holds. The fourth dimension, time, is a fascinating concept that challenges our perception of reality. It's a realm that we're only beginning to understand, a realm that holds the potential for incredible scientific and philosophical breakthroughs. The fourth dimension, then, could be a realm of unimaginable possibilities. If we could navigate this dimension as we do with the others, who knows where we might go, what we might discover, or who we might become. The concept of the fourth dimension is not just a philosophical curiosity, it's a fundamental part of modern physics. When we talk about the fourth dimension, we're stepping into the realm of theories like relativity and quantum mechanics. These theories, which have revolutionized our understanding of the universe, hinge on the concept of the fourth dimension. Consider Einstein's theory of relativity. It merges the three spatial dimensions we're familiar with, length, breadth, and height, with time, creating a four-dimensional fabric known as space-time. It's this space-time that bends and warps under the influence of mass and energy, giving rise to what we perceive as gravity. Similarly, in the baffling world of quantum mechanics, the concept of the fourth dimension is paramount. It allows for the existence of quantum superposition and entanglement, phenomena that defy our everyday logic. So in a way, even if we can't see or touch the fourth dimension, we are already using it. Let's take a step back and ponder over what we've discussed about the fourth dimension. We began by unraveling the enigma of dimensions, understanding them as the spatial and temporal parameters that define our reality. We then plunged into the mystery of the fourth dimension, recognizing it not as an alien concept, but as the very essence of time, a continuous unidirectional flow that governs our existence. Our exploration didn't stop there. We dug deeper and realized the profound significance of the fourth dimension in science. It's the cornerstone of Einstein's theory of relativity. It shapes our understanding of the universe, and it's key to the unification of quantum mechanics and gravity. So in essence, the fourth dimension isn't just an abstract concept, but an integral part of our lives, shaping our understanding of the world and the universe beyond. Next time you look at your watch, remember, you are looking at the fourth dimension, a world beyond our perception, yet intertwined with our reality.